Okay, this is the College Algebra Exam 3 review. We're going to look at question 1 here. So we want to solve the equation of polynomial inequalities. So let's look at part A first. We have x squared plus 7x plus 10 is equal to 0. So a quick one for this one is we can just factor. So we want to know what two numbers multiply to give us 10 and add up to give us 7. So two numbers that multiply to give us 10 are going to be 5 and 2, right? And those also add up to 7. So we're going to have factors of x plus 2 and x plus 5 are equal to 0. So now what we have to do is set each of them equal to 0. So x plus 2 is equal to 0. X plus 5 is equal to 0. So we know our two answers are going to be x is equal to -2 and x is equal to -5. I write that with our curly brackets of -5. -2. We write the -5 first because it's smaller. Now looking at part B here, we have x squared plus 7x plus 10 is greater than or equal to 0. So for here, we're going to have the same factor we had before of x plus 2, x plus 5 is equal to 0. So we know that x is going to be equal to -2 and x is going to be equal to -5, just like before, right? But for this one, we also want to know when it's greater than 0. So what we're going to do is create our number line and have -5, -2 here. We're going to test values on each side of it. So first value we can test is -6. So if we plug -6 into our function, so we're going to do -6 squared plus 7 times -6 plus 10. So when we do that, we get so it's going to give us a positive number there. So we test something between -5 and -2. Easy one's going to be -4 squared plus 7 times -4, and then plus 10. This is going to give us a negative number because this is -2. This one was +4. So we're going to mark this as negative here. Now we want to test something greater than -2. Easy one's going to be 0. 0 squared plus 7 times 0 plus 10. It's going to give us a positive 10, so that's going to be a positive number. So we know that this equation is going to be positive and equal to 0, or greater than or equal to 0, when our x is less than -5 or equal to 5, and when it's greater than -2 or equal to -2. So how we're going to write that is negative infinity. We're going to go to -5, and we're going to include it because it's equal to there. Then we're going to do our union, pick back up at -2 because it's equal there. Let me write that 2 a little bit better. 2. Then we're going to carry on to infinity. That's where it's also greater than 0. Then now continuing with part C, we're going to just mark that as part B. Continue part C in the same color. We want to know when it's less than now, right? So x squared plus 7x plus 10 is less than or equal to 0. Just going to use our same number line that we used up here, and I'm going to copy it. Move it down here. So here we said that our function is less than 0 between -5 and -2 and equal to 0 at -5 and -2. So what we're going to do here is just write -5 to -2 included, because that's the domain in which it's valid. So -5, -2. So now looking at part D, going to do it in the same color of red. We want to know when x squared plus 7x plus 10 is greater than 0. So going back to our number line, we have that -5, -2 here. We said when it was less than -5, it was positive. Between -5 and -2, it was negative. And greater than -2, we said it was positive, right? So we're going to, but we don't want to know when it's equal to 0 now, just when it's greater than. So it's going to be from -infinity to -5. We're not going to include -5 this time. Pick back up from -2 to infinity. We don't want to include -2 because we don't want to know where it's at 0, just when it's greater than. So next we look at question 2. We want to solve the rational inequality x plus 1 over x minus 5 greater than or equal to 0. So we want to find these critical points. So we have our zeros are going to be when our numerator is equal to 0. So x plus 1 is equal to 0. So we're going to subtract 1 on both sides. So 0 at x is equal to -1. And then we also want to set our denominator equal to 0 to find another critical point of our graph. So x minus 5 is equal to 0. So mean that x is equal to 5, we have a critical point. But that's not going to, we can't be equal to 0 at this point because it's in our denominator. If we have 0 in our denominator, then we have our function blows up, right? So now we want to create a number line to figure out when our function is greater than 0. So we have -1 here and 5. So we want to plug something in that's less than -1. So like -2 plus 1 over -2 minus 5. So with -1 over -7, which is a positive number, right? +1/7. So here we're going to put a positive. Between the two, easy one's going to be 0. So 0 plus 1 over 0 minus 5. It's going to be -1/5. So it's going to be a negative number. So between the two, we're going to have, it's going to be negative. Now let's try something greater than 5. Easy one's going to be 6. So 6 plus 1 over 6 minus 5. It's going to leave us with 7 over 1, which is a positive number. So when we're graded there, right? So writing our domain now, I'm just going to erase this for space. So we're greater than 1 from -infinity to -1. But we also want to know when we're equal to 0. So we're going to include our -1. Then we're going to do a jump because we don't want any negative values. And then we're going to pick back up at 5. We're not going to include it because it can't be equal to 0 there. Then we're going to go to infinity because that's also where it's positive. Okay, now looking at question 3 here, we're going to solve the following inequalities. Let's start with A. So A is x times x minus 3 is greater than or equal to 18. So one thing we want to do is we make everything on one side and simplify as far as we can. I'm going to start by distributing our x to make it x squared minus 3x is greater than or equal to 18. Next, I'm going to move that over. So minus 18 on both sides, minus 18. So now we're going to be left with x squared minus 3x minus 18 is greater than or equal to 0. So now we want to find our zeros for this, or our factors as well. So we want to know what two numbers are going to multiply to give us -18 and add up to give us -3. So first thought, two numbers that multiply give us 18 are 6 and 3. So in order for this to be -3, we're going to have an x minus a 6 and an x plus a 3, right? And that's all greater than or equal to 0. So we want to set each one of those greater than or equal to 0. So x minus 6 greater than or equal to 0 and x plus 3. Essentially, just want to do equal to 0 to find out where our zeros are, and then we can decide where they're greater than afterwards. So we know that x is going to be equal to 6, and x is going to be equal to -3. So now we're going to do our number line of, we're going to have -3 here and 6 here. We want to determine what numbers are going to be, what it's going to be whenever we're less than -3, between the two values, and greater than 6, right? So let's go back to just this part, the x minus 3 times x plus 3. So we want to plug in a number less than -3. So let's try -4. So we're going to -4 minus 6 times -4 plus 3. And that's going to give us a value. So that we only want to know what if it's positive or negative. First one's going to be negative. This is also going to be negative. Negative times a negative is going to be a positive. So we're less than -3. We're positive. So between the two values, easy one's 0. So we're going to do 0 minus 6 times 0 plus 3. We're going to have a negative times a positive. So we're going to have a negative value there. So put that down here. And then we want to do something greater than 6. So just do 7. So 7 minus 6 times 7 plus 3. It's going to give us a positive and a positive, which is a positive number. We have positive when we're greater than 6. So we want to know when our function is greater than as well. Greater than or equal to 0. So when we write that, I'm going to erase this for some room. We write that out. We're greater than from -infinity to -3. We're going to include -3 because that's where it's 0. Then we're going to pick back up, and we're going to include 6 because it's a 0 there. and then go to infinity, that's where it's greater than 0. So now we want to look at part B here. So B has x squared minus 2x plus 4 is less than or equal to 3. Let's get everything on one side. So we're going to subtract 3 on both sides. So minus 3 minus 3. So we're going to have x squared minus 2x plus 1 is less than or equal to 0, right? So now we want to factor this and see what numbers will multiply to give us positive 1 and add up to give us negative 2, right? So numbers that multiply to give us 1 are going to be 1 and 1, or negative 1, negative 1. So in which one, if we're going to choose positive or negative, well, we want to know what adds up to give us negative 2, so it's going to have to be negative 1s. 0. So we know that x is going to be equal to 1 when we set, so before we do that, we need to set x minus 1 equal to 0. So we have a 0 at x is equal to 1. So now you want to test that function on either side and see where it's less than. So let's go with plugging in numbers that are less than 1, so like 0, into our function. So 0 squared minus times 0 plus 1 is less than or equal to 0. Well, we want to see if it is or not. That's going to give us just 1, which is a positive number. So we're going to have positive there. Let's try a number that's greater than 1, like 2. So 2 squared minus 2 times 2 plus 1. It's going to also give us 1, right, which is a positive number. So we know the only point on our function where we satisfy the less than or equal to is at 1. Now looking at question 3, part C, we have 8 over 3x minus 4 is less than or equal to 1. So to do this one, we need to multiply both sides by 3x minus 4 squared. And we have to multiply both sides by the squared of it to make sure we account for all solutions. Right? So one of these is going to cancel out with that bottom, right? So we're left with 8 times 3x minus 4 is less than or equal to 3x minus 4 squared. I forgot the square there. That is a square. So in our left side, we're going to have 24x minus 32 is less than or equal to. We're going to FOIL this out because it's the same as writing 3x minus 4 times 3x minus 4. That's going to leave us with 9x squared minus 24x plus 16. So now we want to get everything on one side. So I'm going to subtract both sides by 24x. It's 24x. I'm also going to add the 32 plus 32. So we're going to have 0 is less than or equal to 9x squared minus 48x plus 48, right? So now what we want to do is find our factors. So easy way for this one is we're just going to use the quadratic equation. So minus b plus or minus the square root of b squared minus 4ac all over 2a. That's what our x is equal to. So in this case, we're going to have minus a negative 48 plus or minus the square root of negative 48 squared minus 4 times 9 times c of 48, and then all over 2 times 9, right? That's going to leave us, plugging into our calculator, it's going to leave us with two x values, one of 4 over 3 and 1 of 4, right? So 4 over 3 is roughly 1.33, just for our number line purposes, less than 4. So now I want to plug it on and see where it happens where that value is greater than 0. So 4 over 3 and 4, those are our two roots. And those are where our function is equal to 0. So now I'm going to test anything less than 4/3. Easy one's going to be 0, right? So we're going to do 9 times 0 minus 48 times 0 plus 48. That leaves us with 48, which is a positive number, right? So we're going to put a positive here. Now I want to test them between 4/3 and 4. easy one there is going to be 2. So we're going to have 9 times 2 squared minus 48 times 2 plus 48. That leaves us with a negative 12, which is negative, so we're going to put it below our number line. Next, we're going to try something greater than 4. Simple one's going to be 5, so 9 times 5 squared minus 48 times 5 plus 48. Plug that into our calculator. 9 times 5 squared minus 48 times 5 plus 48. It's going to give us 33, which is positive, so we're going to be up here. Just going to erase this stuff for space. I don't know, let me erase that. All right, now we want to know when that is greater than or equal to 0, right? So we know anything less than 4/3 is greater than 0. So we're going to have negative infinity to 4/3. We need to test 4/3 to make sure it is a 0. So we plug it back in to our original equation of 8 over 3 times 4/3 minus 4. Right, so we plug it back in here, we're going to get a function that does not exist. We're going to have a 0 in our denominator, right? So we can't include the 4/3. We're going to just put parentheses there, union. We know 4 is going to be a 0. I'm going to do bracket from 4 to infinity.
Okay, I'm going to be working on 3D. So we have 3 over x minus 2 is less than negative 2 over x. So I think my first step here is I'm going to get everything to one side and then try and get them under the same denominator. So, if I move this to the opposite side by adding it, we'll have this expression here. And now I want to get these two here to have the same denominator. So I'm going to multiply the left fraction by x over x and the right fraction by x minus 2 over x minus 2. So I'm going to have 3 times x over x times x minus 2 plus 2 times x minus 2 over x times x minus 2 is less than 0. So now that these have the same denominator, we can just go ahead and directly add them and then combine our like terms. So we'll end up with 5x minus 4 over x times x minus 2 being less than 0. So now what we want to do here is identify where this is equal to 0 or does not exist. Then we're going to make a number line here. So where does this not equal 0 or does not exist? It's going to be right here whenever x is equal to 0. Whenever x is equal to 2, we don't exist, so we need to mark those points. Then we're going to equal 0 whenever this top part equals 0, which will be at x equals 4/5. So we get that 4/5 by doing this here. So we would add 4 to the other side and then divide by 5, so x equals 4/5. And then x cannot equal 0, and it cannot equal 2. So next we're going to make a number line here. And we're going to mark these points on it. So we're going to have, put 0 right here, put 4/5 here, and then 2 here. So next what we want to do is just think of some numbers in these like gaps here that we can plug in here to check if it's less than or greater than 0. So a number less than 0 that we could plug in is, say, -1. So if we plug in -1 into this expression right here, I'll make a little star next to it. Oops. So we would have -5 minus 4 over -1 times -3, and this would be equal to -9 over +3, or just -3. So here, if we plug in a number smaller than 0, we should expect it to be negative. Okay? So then we're going to try another number. So maybe something between 0 and 4/5 that we can do, such as 1/2. So if we plug in 1/2, we'll have 5/2 minus 4 over 1/2 times -3/2. And if we evaluate this, notice this top portion here is going to be negative, and this bottom portion here is going to be negative. So even without like going through and plugging in the numbers, we can go ahead and see that this is probably going to be positive here, because we'll have some negative over another negative. So we should expect this to be positive. And then we can go ahead and plug in a number between 4/5 and 2. So maybe we plug in 1. So if we plug in 1, we'll have 5 minus 4 over 1 times negative 1. And this is going to equal, we'll have 1 over negative 1. So negative 1. So we got a negative number, which means that we're going to be negative over this interval here. And then next we plug in a number greater than 2, such as 3. That means that this is going to be 15 minus 4 over 3 times 1, which is all going to be positive. So we know that everything past this point is going to be positive. So now going back to our original equation here, what we had, we wanted to look for when is this less than 0. Well, we can see it's less than 0 over this interval and this interval. So now we just need to write that in interval notation as our answer. So we say that this inequality is going to be true from negative infinity up until 0. And we're going to use parentheses because notice this isn't less than or equal to, and also we don't even exist at 0. So we can't have brackets there and say that that's included. And then our next interval is from 4/5 to 2. Then we're also going to use parentheses on both of those because it's not less than or equal to. And we also want to put a union symbol between the two. And that's our answer there. Okay, number 4. So you have an advertising agency who wants to maximize profit. They can choose to pay for advertising or let word of mouth advertise for them. The agency expects the profits with advertising to follow this relationship and the profits from word of mouth to follow P of M. Time T is given in days. During what intervals of time would word of mouth maximize profit? So when P of A is less than P of M, answer with a complete sentence and show all work. So when P of A is less than P of M. So let's just write this out. So P of A is 1 over 7, T squared minus 4 over 7, T plus 2. When is this less than profit from word of mouth, which is T plus 2? So the first thing I'm going to do is move everything to one side. So I'm going to subtract T from both sides and subtract 2 from both sides. So I end up with 1/7 T squared minus 11/7 T is less than 0. So next, I can go ahead and factor out a T from both of these here. And you write this as T times 1/7 T minus 11/7 is less than 0. So next we want to see when is this thing equal to 0. Then we can make a number line and figure out that interval where we're less than 0. And also we know that T is always going to be greater than 0, just because we can't have like negative days. So we know T must be greater than 0. So we see here that this will equal 0 whenever T equals 0. I guess it's technically greater than or equal to 0. So we see T equals 0. Then we have 1/7 T minus 11/7 equals 0. We get that T equals 11. So from here we can make our number line. So right here we have 0, and then right here we have 11. So now if we go ahead and plug in a number between 0 and 11, say 1, we can go ahead and see that this is going to be right here. Right here is where we want to plug it in. We'll have 1 times 1/7 minus 11/7. So this is going to be, oops. You can see that this is going to be, we'll have 1 times negative 10 over 7, which is, in fact, less than 0. Let's go ahead and put a negative mark right there. And then if we plugged in a number greater than 11, like let's say 12, we should see that this portion here, this portion here, if we plug in, say, 12, we'd have some positive number times this would be 12/7 minus 11/7, which would be just positive 1/7. So we should expect that anything greater than 11, we will get a positive answer, which means that this here is our interval. This is whenever this function is less than 0. or whenever the profit from advertising due to word of mouth would be more than the profit from just paying for advertising. So we say from 0 to 11 is whenever is like the interval of days where word of mouth would maximize profit. Okay, for number 5, we're going to determine if the relation defines y as a function of x. And what that means is that if you plug in x, you get one y value. So another common way to check for that is if you do something like the vertical line test, which is where like you imagine your pencil going vertical up and down, and you just move it along the graph, and you want to see if at any point you have sort of like two different x values, two different y values at the same x. So an example of something like that would be something like this. This is not a function or it's not one single function, because if we notice at this x value, we could either be at this y or that y. So we say it's not one function. So if we go ahead and look at 5a, what we see is that we're given some points. So what we want to look for is there an x coordinate that has two different y's? So we have -10, 4. Okay, -2, that's a new x coordinate. We have 6, that's a new x coordinate. We have 14. These are all new x coordinates with their own y, or with their own y. And what's important is that, for example, if they added this point here, like say -10, 5, it would no longer be a function. So we're looking for whenever we put an input in, if we get two separate outputs, not a function. So for A, yes, this is a function. Okay. For B, I'm presuming that this is sort of like your inputs here, like these are like your x's and these are your y's. So we can see that we have sort of like the point 213 on our graph, or our function. We have 325 and 425. So this one is also good for a function because we did not get two separate x values or two separate x coordinates. So moving on to part C. Okay, part C. Notice this graph does not pass the vertical line test. So if we imagine a vertical line at any of these points, notice we touch this graph at many different points here. If we go through here at like 1, you can see it touches at several different spots. So we'd say, no, this is not a function, because if we put in f of 1, it could be any one of these spots, which is why we say, no, it's not a function. Okay, for 6, we're going to determine if the functions are one-to-one and give an explanation. So generally a good approach is to try and graph your function and then do a horizontal line test. So for graph A, we have something like this here. So you see we're going to go up like that and then down here like that. So if we imagine passing a horizontal line through here, it should only touch our graph at one spot, because for every x there's only one y, and for every y there's only one x. That's what one-to-one means. So we see that like right here there's this x coordinate and there's this one y coordinate, and there's no other x value for this y coordinate, and there's no other y value for this x coordinate. So because of that, we say that this one here, A, is one-to-one. Okay, next for B, we have x squared minus 6. So if you go ahead and imagine graphing this, we might have something kind of like this. It's going to be a parabola. So if we do our horizontal line test, say like right here, notice we pass through two separate points. So at this y coordinate, we have both of these x values, which means that it's not one-to-one, because we have two separate ways of getting a particular y value. So again, if you just imagine like taking your pencil it's hard to show on the video, but if you take your pencil and you like set it down going like this, then you move it upwards through the graph, you want to look for if you pass through the line at two separate spots, just like you do here and here. That would mean that you do not pass the test to check if it's 1 to 1. So B here is not 1 to 1. Okay, and then C here actually gives us the graph. So if we imagine, say, we set down our pencil at this point here too, notice we get a whole bunch of different x coordinates for y is -2. We have 2, we have 4, we have -2, and we have around -4. So because for that particular y value there's several different x coordinates, we would say that this function is not 1 to 1. Okay, working on 7 here. Use composition of functions to determine if the two functions are inverses. Show all work. So what we're going to do is we're going to plug f in for g, or vice versa. And if we get x from simplifying, then that means that the functions are inverses of each other. Okay, so starting with a, we're going to have f. Let's go ahead and we'll go ahead and plug in g into x, or excuse me, g into f. So what that would look like is we're going to have 4 over g of x minus 1. So what's g of x? G of x is x plus 4 over x. So what we'd have from here is 4 over x plus 4 over x minus 1. Okay. So from here, we just need to do a little bit of simplifying. So what we can do is maybe try and get a common denominator between these two here. So we can go ahead and do that by multiplying this by x over x. And if we do that, we have x plus 4, or well, this is all over 4. X plus 4 over x minus x over x. So now we can combine these two, and we would get 4 over 4 over x. So from here, we can take this one down here and bring it up here, and then cancel those two out. And we multiply by x over x. This cancels with that. And then the 4's divide each other out, and we're just left with x. So because we just got x, that means that yes, these are inverses. And it's also a good idea to check if the opposite is true. If we plug if we plug f in for g and we get the same thing, then they're also inverses. Okay, for b, we have r of x equals -2 plus x divided by 6, and s of x equals 6x minus 2. So what we do to check if they're inverses, we plug one into the other. So if we plug s in for r, so r of s of x is going to equal, we'll have -2 plus 6x minus 2 over 6. So from here, we get that r of s of x is equal to 6x minus 4 over 6. So notice this does not equal x. So because this does not equal x, r and s are not inverses of each other. Okay, 8a. So each function is one-to-one function. Find the inverse function. Give your answer in inverse function notation. Show all work. So generally, there's sort of like two different ways that they describe finding the inverse function. One of them is you solve for x and then apply your notation. The other one is they say you swap your x and y or x and f of x and solve. So they're really the same thing. It's just sort of two different ways to describe it. So what I'm going to do for this question is I'm going to say that to solve our inverse, it's going to be x is equal to the cube root of 2 times f inverse of x minus 5. So I'm going to use this notation here to solve it. So the first thing that I'm going to point out is that whenever we have a cube root, that's the same thing as saying that we have something like this here to the 1/3 power. So if it was a square root, it's the same thing as writing it as the 1/2 power. So, and then the way that we undo this is we take it to that power in the denominator right here. So to undo a cube root, you cube it. Okay, so if we do that, we get that x cubed equals 2 times our inverse of x minus 5. So if we want to solve for our inverse, we add 5 to both sides, and then we divide by 2. So we get that our inverse, f inverse of x, is equal to x cubed plus 5 divided by 2. So, okay, 8b. So we're going to do a similar thing that we did last time, where we're going to plug in our inverse for x and then x for f of x. So we have x is equal to f inverse of x minus 4 over f inverse of x plus 2. So the first thing that I'm going to do is multiply both sides by this f inverse plus 2, just to get everything out of the denominator. So we have x times f inverse of x plus 2 equals f inverse of x minus 4. So next, I want to get what I'm solving for all on one side and then isolate it. So I'm going to subtract our inverse to the left side and then subtract the 2x to the opposite side. So we have x inverse of x minus f inverse of x equals 4 minus 2x. So again, I just subtracted this to this side, and then I took this and then just subtracted it to that side. So next, because both these have an f inverse in common, I'm going to factor it out. So I get to write it like this. This is all times x minus 1 equals, oh, sorry, I just realized this is supposed to be negative here. Yeah, sorry. So we're going to have negative 2x minus 4. So now that we have this here, we get to divide by x minus 1 on both sides. And that'll get us that f inverse of x equals negative 2x minus 4 over x minus 1.
So looking at question 9 here, we want to evaluate the function f of x is equal to 6 to the power of x at the given x values, round to 4 decimal places. Okay, so let's first start with f of negative 3. We're going to plug that in, just 6 to the power of negative 3. Plug that into our calculator, negative 3. And that's going to give us 0.0046. Now let's go to the next one. F of 3.8. We're going to have 6 to the power of 3.8. Plugging this into the calculator, 6 to the power of 3.8 is going to give us 905.6799. So now we want to do the next one of f of square root 13. We're going to have 6 to the power of square root 13. It's going to give us 6 to the power square root 13, 639.2404. And then f of pi now. So now we're going to do 6 to the power of pi, which that's going to leave us with 278.3776, right? And just a quick reminder, whenever you plug this into your calculator, you're going to plug it in something like 6, have the little caret, and then make sure you put parentheses around everything that you want to bring to the power. That way it registers in your calculator correctly. Okay, now looking at question 10 here, we want to graph the exponential function f of x is equal to 4 to the power of x. We want to use a table. So let's just write a table out real quick. So x here, 4 to the power of x here. And then let's just create x values of some easy ones like -2, -1, 0, 1, and 2, right? And then I'm going to insert a graph real quick. That way we can graph it. All right. Insert this one. Let me shrink it. We're going to put it right there. Okay. So first we need to fill out this graph by plugging our values of x into our function. So like f of -2 would be 4 to the power of -2, which is going to be 4 to the power of -2, which is going to be 1 over 16. So 1 over 16. Now f of -1, 4 to the power of -1, is going to be 1/4. So 1/4. And then f of 0 is going to be 4 to the power of 0. And remember, anything to the power of 0 is just 1. Plug that in here. Now we want to do f of 1. 4 to the power of 1 is going to be 4. And then f of 2, 4 to the power of 2, is going to be 16. So we have 4 here, and then 16 here. Right, so we're going to ignore on this graph that we have these bounds. I'm just going to cross them out. And we're going to create our own domain in range here, or our own x and y values. We're going to do our x scaling by factors of 1. So 1 here, 2, 3, 4. Then our left side, our -1, -2, -3, -4. But in our y direction, right, we want to do probably by factors of 4. So we're going to have 4, 8, 12, 16, and then -4, -8, -12, -16, right? So we know when our x is equal to -2, our y is equal to 1/16. So -2/16 will be somewhere kind of like there. -1/4, slightly larger. It's going to be kind of hard to mark it exactly on this graph just by the scaling. We know we have 0, 1. It's going to probably be about right there. Or 1, we want to be 4, so we're going to put it right here. And then 2/16, so we're going to come all the way up here. If I draw this now, it's going to look something like that. Continue both directions. And now to write our domain in range of this function. So our domain comes from -infinity. That's going to go on forever in the infinity direction, right? And then our range is going to be, we're going to start at 0 because our function can never be smaller than 0, but it never actually reaches 0 either, so we can't include it. And we're going on forever in our y direction to infinity. So next we're going to look at question 11 here. We're given the graph of f of x is equal to 1/2 to the power of x, graph g of x, and g of x is equal to 1/2, got that half a little better, 1/2 to the power of x minus 3 plus 2. So, and we also want to state the shifts. So our shifts, so first we want to look at anything moving in a horizontal direction, right? So we have this x minus 3 here, meaning that we're going to shift right 3 units. And then we're going to look at this plus 2 second, because that's controls our y, and that's going to shift up 2 units. So next I'm going to pull out this graph and make it larger so we can draw on it. Okay, so now I'm going to draw right over this one, and we can shift that up, right? So we're saying we shift right 3 units. So if I can grab just that line. So we have a point at 0, 1. So we can need to move that over. We can see there. Move that point over. 1, 2, 3, right? And that also shifts over this point. We have right here is a known point. 1, 2, 3, just to check ourselves. Here's a known point. 1, 2, 3. Still there, right? Here. 1, 2, 3. It's pretty close. I kind of drew it, not the straightest. Typically, you want to also just find what those points are and move them over. Like we can say I have a point at 0, 1. What is this one? -2, 4. And we're saying we're shifting those right 3 units. So it's going to be at, now we're going to be at 3, 1. And this one's going to be at 1, 4. Right? We went right 3. And now we want to go up 2. Right? So that's going to put us at 3, 3. And then 1, 7. Now if I grab this graph here, this is our 3, 1 point. So we're going to, let me grab it. So 1, 2. Now we can see over here we have a point at 1, 2, 3, 1, 2, 3, then 1, 2, 3. It's at our 3, 3 right there. So right here we're at 3, 3. We also said we should have one at 1, 7. So 1, and then 1, 2, 3, 4, 5, 6, 7, which we do. So now we can see that our graph matches up what we said our shifts were going to be. Okay, now looking at question 12. Cara needs to borrow $15,000. She has 3 options to choose from. 5.5 simple interest for 4 years, 5.25% interest compounded monthly for 4 years, or 5% interest compounded continuously for 4 years. So how much interest would Susan pay for each option? Well, first we want to write out our equations for each one. So we know that our simple interest equation, simple interest, if I can spell that right, that looks right. That equation is going to be A is equal to P1 plus RT. And then our compounded monthly, so compound monthly, or should compound not continuously equation. So it's going to be, making sure I got that. So A is equal to P1 plus R over N to the power of NT, where N is the number of times interest is applied per time period. So in our case, so we're monthly, we're going to put 12 there. And then the continuously, I got to remember how to spell continuously real quick. I guess it's right there. Continuously. That equation is P is equal to P naught E to the RT. So now we can start plugging in our values, right? So she needs to borrow $15,000. That's going to be our initial, right? So we're going to start with simple interest. Simple. So we know that she needs to borrow that $15,000. So we're going to plug that in for initial P. So 15,000. Then 1 plus our rate, which is 5.5%, right? We have to divide that by 100 to get it into decimal. It's going to be 0.055 times T, which T is always in years, so this is going to be 4 years. So when we plug this into our calculator, we're going to get 15,000 times 1 plus 0.055 times 4. It's going to leave us with 18,300. Write that a little bit better. 300. That gives us how much we have in our account at the end of the time. So to find out how much interest we paid, we need to subtract this and then minus our 1,500. So our I for interest is going to be 18,300 minus 15,000, and that's going to give us 3,300, right? So we want to do our compounding continuously. Compound continuous, I'm just going to put that. So that equation is A is equal to P1 plus, I don't really need to rewrite it, right? We already have it. So A is equal to that 15,000 times 1 plus our rate for this one is 5.25 divided by 100 to get it into a decimal. So 0.0525 over N, which in this case is 12, and then being raised to 12 times 4. Plugging this one into our calculator, we're going to get 15,000 times 1 plus 0.0525 over 12. Then everything in the parentheses being raised 12 times 4. That's going to give us 18,496. And we want to go to 2 decimals because that's how much money is, right? So it's 696, so we're going to round that to 70. So now to find our interest for this one, so IC, this one isn't the compounded continuously, I'm sorry, it's the compounded monthly. So ICM for monthly, we're going to do 18,496.70 minus 15,000, and that's going to be our I for our compounded monthly, is going to leave us with 3,496.70, right? So now we want to do our compounded continuously, which is going to give us P is equal to P0 e to the RT, which we already know. I already wrote it. So P0, P naught, either way, is at 15,000. E being raised to our R, which in this case is 5%, so 0.05 times our time of 4. Plug that into our calculator. 15,000 e to the power of 0.05 times 4. And that's going to give us 18,321.04. Now we want to know our interest for our compounded continuously. That's going to leave us with that 18,321.04 minus 15,000. It's going to leave us with our I compounded continuously equal to 3,321.04 in dollars, right? Don't want to forget the dollars. So, dollar, 3,321.04. So, that's going to be our answer for part A. And then now we know that we want to know which option best for Suzanne, assuming that she wants to pay the least amount of interest possible. Well, we're going to look at each of our interests and determine which one was the smallest. So that's going to be our simple interest, because it's 3,300, which is smaller than 3,321 and 3,400. So our simple interest is smallest, which is our best for Suzanne. Okay, looking at question 13 here. A veterinarian depreciates a $10,000 X-ray machine. He estimates the resale value V of T in dollars after T years is 90% of its value from the previous year. Therefore, the resale value can be approximated by V of T is equal to 1000 times 0.9 to the power of t. So it wants to know after 4 years. So t is in years, right? So we can do v of 4. So we're going to plug in a 4 anywhere we see a t. It's going to be 10,000 times 0.9 to the power of 4. So v of 4 is equal to 6,561. So for part A, the resale value of the X-ray machine after 4 years is $6,561. Now we look at part B. I'm just going to draw like a little line. The veterinary wants to sell his practice 8 years after the X-ray machine was purchased. How much is the machine worth? Round to the nearest hundredth. So now what we want to do is plug in 8 for V of t. We're going to have V of 8 is equal to 10,000 times 0.9 the power of 8. So V of 8 is equal to 10,000 times 0.9 to the power of 8. It's going to leave us with 4,304.67, but it wants us to round to the nearest $100, $100, I should say. So V of 8 is approximately 4,300. So the X-ray machine is worth $4,300 when he sells it. When he sells his practice after 8 years. Right, looking at 14a here, we have log base 5 of 125 is equal to 3. So logs essentially want to know what power to the base gives us what's inside of our log, right? And what we can do is our like flip method, right? Change it. So we know that 5 to the power of 3 is going to equal 125. Right, we can do a quick check in our calculator. If we check that, 3 gives us 125, right? That's part A. So then part B, we want to know natural log of x plus 4 is equal to 3. So another way to write a natural log is log base e to x plus 4 is equal to 3. So we're going to do our flip. So we want to know e to the power of what gives us x plus 4. We'll do this little flip method again. So know that e to the power of 3 is going to give us x plus 4. Then part C, we're given log base kr is equal to m. Same thing again. We want to do our little flip. We want to know what to the k to the power of what gives us r, which is going to be our m value. So k to the power of m is going to leave us with r.